Hello everyone, we are Group 8 presenting our database management system final project, an online course management system. Our team includes Hong Anh, Chang, Dong and myself, Joy. Today we'll guide you through our system objectives, its database and application design, key implemented features via GUI demonstration, and conclude with our achievements. Our primary objective, as stated, was to build the online platform for course management. We focused on achieving several core goals: centralized data management, distinct user roles with appropriate access, and automate progress tracking for learners, and ensuring secure interaction between the application and our database. For the system foundation, we utilize MySQL as our relational database management system, with Python and the Flash framework serving as the backbone for its user-friendly graphical user interface.
My name is Dong and this is my presentation. Okay, let's dive into our database structure, visualized here by our entity relationship diagram. In this diagram, a key design decision was the introduction of a central users table. This table handles all user authentication, like email, password, and role assignment, whether a user is an admin, instructor, or learner. This centralized approach enhances security and simplifies user management. The users table then links to more specific profile tables, like learners for student-specific data like phone number, and instructors for data like expertise. This ensures that common user attributes are not duplicated. For course operations, courses store course details and a link to an instructor. Each course can contain multiple lectures. Learners enroll in courses via the enrollment table, which is crucial as it also stores their completion status and progress percentage. As you can see, a learner's interaction, such as viewing a lecture, is recorded in lecture views. This event then triggers mechanisms to update progress in the enrollment table. Finally, enrollment logs provides an audit trail for key enrollment actions. In this slide, our entity relationship diagram translates into a well-defined relational schema. Here are highlights for key tables. The user table, for example, uses email as a unique non-node identifier for logins. The password column, as Joanne mentioned, will store hash values processed by our Python application. Profile tables like learners are tightly linked to users via a user ID foreign key, which is also unique and non-null, ensuring a clear one-to-one mapping from a user account to a learner profile. Deleting a user account will cascade to delete the associated learner profile. The enrollment table is critical, linking learners and courses. This includes non-null fields for enrollment date and progress, with default values ensuring consistency from the moment of enrollment. Across all tables, we have rigorously applied primary keys, foreign keys with specific on-delete actions like cascade or set null, unique constraints for fields like emails, and non-null constraints for essential data, all to maintain high data integrity and consistency.
To build a dynamic and efficient system, we leverage several advanced SQL features. Views like learners' core progress provide an accurate look at student progress, including their emails for easy identification, while instructor teaching logs help admins see instructor assignment. Outdoor procedures streamline common tasks. Enroll learner handles the logic for new enrollments, including preventing duplicates. Generate Completion Summary provides a detailed report on how learners are progressing through a specific course. The Calculate Completion Rate user-defined functions is essential to our progress tracking, accurately determining the percentage of a course a learner has completed. Finally, Trigger acts as our automation engine. Log new enrollment keeps an audit log. Check view date after enrollment enforce data integrity. Most significantly, the update enrollment progress trigger files every time a lecture is viewed. It calls out calculate completion rate functions and instantly update the learner's progress percentage and completion status in the enrollment tables. This is what enables the real-time progress tracking you will see in the demo.
Our graphical user interface is a web application built with Python using the Flask framework. As you can see in our architecture, user requests from the browser are handled by Flask routes defined in main.p. These routes then call functions within our manager modules, which encapsulate business logic and database interactions connecting to MySQL via a dedicated DB_connector. Here are three role types and permissions in our app: learner, instructor, and admin. Security is paramount. Authentication is managed by our user_manager.p, which verifies credentials against the user's table. It's important to note that while our SQL sample data use placeholder password for simplicity, the Python application is designed to handle secure hash password. Once authenticated, role-based access control implemented with Flask decorator like @login_required and @role_required ensures users can only access appropriate sections and features. Furthermore, on database queries originating from our Python code are parameterized to prevent SQL injection vulnerabilities. Now we'll proceed with a live demonstration of the system, showcasing the functionalities available to each user role. I will start with the administrator portal. Here is the homepage of our website. I will log in as an admin. The admin dashboard provides an overview and access to all management modules. Administrators can manage all user accounts, including learners and instructors. Here is the list of all the learners. You can search the learner by ID, name, or email. And you can see the details of the learners. Let's add a learner. The new learner appears here. Admin can also edit the learner and or delete the learner. Let's edit the name of this learner, Wonderland 2. You can see the new name of learner. Or delete this learner. For the instructor, you can do the same functionalities like the learners. You can add, see the details, edit, and delete. Next, managing courses. Here we see all available courses along with their assigned instructor. An admin can create new course. And assign it to some instructor. The new course appear here. And the admin can also update the course or delete the course. For each course, admins can manage its lectures, create new lecture like or edit it, and delete lecture. Admin also have access to key system reports. For example, the instructor workload report and the active courses. Here we can select a course and see the progress of all enrolled learners. This demonstrates the admin's comprehensive control over the platform's core data and insights into its operation.
Thank you, Chang. Now I'll log in as an instructor, for example, Dr. Ada Lovelace, to showcase the instructor portal. I have the email of Dr. Ada Lovelace here, and let's log in. Dr. Lovelace's dashboard immediately shows the courses she assigned to teach, such as Introduction to Python, and is well for the beginners. Let's select Introduction to Python. From here, Dr. Lovelace can manage the lectures for this specific course. She can edit an existing lecture, for example, to update the content of variable and data types. You can see the result here. She can also add new lectures as the course evolves. Or she can delete the lectures. A key feature for instructors is viewing the enrollment roster and progress for their courses. Here, Dr. Lovelace can see all the learners enrolled, such as Alice Wonderland and Bob the Builder, along with their current completion percentage and status for this course. This is crucial for instructors to monitor student engagement. The instructor portal empowers educators to effectively manage their course content and stay informed about their students' learning journeys.
Thank you, Choang. Finally, let's experience the system as a learner. I will log in as Alice Wonderland. Alice's dashboard displays her enrolled courses and current progress. Here we can see that she has applied for 3 courses: Introduction to Python, SQL for Beginner, and Relational Database Design. Now let's view Introduction to Python. So we can see that here Alice is still in progress, and currently she has completed 67% of her course. Let's navigate to available courses. Alice now decides she wants to learn about AI, so she will view the detail of this course and click Enroll in this course. Confirmation message appears, and if we return to her dashboard, we can see that now Introduction to AI has been listed in your courses. And if we click on it, we can see that the status is not started and the progress is 0%. Now let's revisit Introduction to Python. Alice wants to continue her learning. The system saw the lecture and she hasn't viewed basic operator yet. After viewing the content, where Alice navigates back to her course list or her progress dashboard, we can see her progress for Introduction to Python has automatically updated to 100% and the status is now completed. This real-time update is a key feature driven by our database trigger that reacts to her viewing the lecture. This demonstrates a seamless learning experience where progress is tracked transparently and automatically, encouraging learners to complete their courses. To summarize, our project successfully delivered a database-driven online course management system with several key highlights. We implemented a centralized user authentication system with a role-based graphical user interface using Flask, ensuring users only access relevant functionalities. Our MySQL database features a comprehensive schema designed for data integrity and efficient querying. A standout feature is the automated real-time learner progress tracking, achieved through intelligent use of SQL triggers and user-defined functions, which you saw in the demo. We have also prioritized secure application database interaction by designing for password hashing at the application level and utilizing parameterized queries through our Python backend. Overall, the system provides robust CRUD operations for all course entities and essential reporting capabilities, forming a solid foundation for an online learning platform.
Nice.
This concludes our presentation and demonstration of the online course management system. Thank you very much for your time and attention.